All right, this is second part of the video, so let's do it quickly. And I was introduced. I did the little homework here, so you don't have to wait. Just go through this. If you can read this, you will understand what the paired data, paired T procedure is. This is called paired data and one sample T procedure. So still we treat as a one sample t-test. However, this is the two, they're asking uh, each individual's difference. Okay, so this, if you read through, there is, they try to find out if it's um, caffeine will affect depression. So that this is experiment. So during 1-2 day period, so they recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subject. Subject means people who become experiment. Like the patients at the hospital could be, and if they try to get a new prescription or even placebo, it's using placebo effect, and it could be you can call them subjects. Okay, so each subject borrowed from caffeine, colas, and substance with caffeine for the duration of the experiment. So then they can't drink coffee, they can drink Coca-Cola, anything like that. Okay, during 2 day periods, subjects took capsules containing their normal caffeine intake. So if they have to take the caffeine, just to take the pill. During another 2 days period, they took the placebo capsule. So the other in which subject took caffeine and the placebo was random. So we don't know which one. The first you take placebo, or first you take the real caffeine, or second period you take a real caffeine. You don't know. So there's a randomized uh, effect, and they try to get the depression rate. Okay, and at the end of the second period, the test depression was given to all 11 subjects. The researcher wanted to know whether being deprived of caffeine would lead to increase of depression. Okay, so the question is, so this is a table. Okay, so subject means human being, so it could be Tony, uh, Thomas, or Nancy. It could be anybody's name here. Okay, then and it could be first day and second day, first day, second day, or could be second day, first day. We don't know which ones they give, which day. Okay, they means doctors, to find out the research. Okay, but we could tell which day they give placebo or caffeine. So we're going to find the differences. Those are the difference data. Okay. So the table below contains the data on the subject's score of the depression test. Higher scores showed more symptoms of the depression. So higher score is a kind of, it's really sad, right? And um, so so the placebo minus caffeine is going to be this one. So my understanding is if if they took placebo, which is non-caffeine, their depression rate most likely, I just look at those two data, most likely they have bigger depression. So coffee helped, my understanding. Okay, so but when we create the hypothesis, we have to make it slightly different way. So these are data here, right? Why did researcher random? And so question A: why did researcher randomly assign the order in which subjects received the placebo and caffeine? Okay, so what if the placebo was given at the first period and second period they get the caffeine? What first period was is everybody had the sunny, right? And second period was if they have a raining day. It might be it's like it's we get the different it's different uh, the effect onto those the experiment. That's why. So if you can read, if you can pause the video and if you can read through, they're talking about similar thing. Okay. Uh, so they try to avoid conflict in the variables here. Okay. Now, so the state is null hypothesis is null of, so they list the null hypothesis mu of d sub d means mu of difference is 0. Okay. And alternatives mu of difference is greater than 0. So placebo minus caffeine must be bigger because we assume uh, uh, placebo is no effect of caffeine, right? So that's why we assume, yeah, we have to make it as a no hypothesis is a no difference. I'm sorry, so no difference. So that's the first thing is that you create the null hypothesis. All right, and it's one sample t test. It's called, it might be called paired test. The plan is if condition are met, we should conduct a paired t test. So I'm sorry, I called one sample t test, but it's actually similar to one sample t test, but it's called a paired t test for mu of difference. Okay. Now, the one slightly difference, because since this is a research base, the random is, they say it's random. 10% it's the 10% we are not sampling, so it's not it isn't necessary to check 10% condition. So but you better write down. Okay. Now, when you enter this, so all you need is this data. Even though this is showing difference, you can enter this and you can let the calculator to come up this one on the, you can put the list 1, list 2, and list 3 is going to be calculated for you, right? But now let's think about this. For you create this data, and I actually enter only this because they give you this data. But sometimes they might not give you, so you might have to know. They only give you those two data, and you have to by doing by hand or just let the calculator to create list 3 to put in. All right. Now, if I enter here, when I edit, I enter page 586, which is this page, which is placebo and caffeine. That only data I enter is here. Okay. So then go to, first you have to go to second stats plot and put 1, and I choose the box plot. Zoom 9 is going to be showing this. So there is no skewness. I think I cut and paste somewhere. Oh, but it's showing here. So let me cut and paste into this page. Right here. Okay, so all right, so no skewness. So you can plug in the other histogram or normality plots, and but it's going to be no skewness so much. It's a little bit skewed, right? But no outliers. So we can conduct the uh, uh, T statistics. T statistic equation is this, and this is from the calculator. You go to stats calculator and one variable test, and I plug in the list is page 586 and go to calculator and get this information, and I cut it, paste here. Okay. Now let's plug in here. So t-test, the mu is right here, 7.363. Okay, so then write down 7 point. So t equal, right? T equal 7.763. I forgot. Now let me fix it later. And the nu was different. It's a new different. Mu of difference is alternative means no hypothesis is 0. Now standard deviation, 6 something. Okay, I put 6 now. Let's see, 6.9. So let me grab this calculator here. All right, so this right here. All right, let's see again. 7.636, 636, 634 actually. 634. 634 minus 0 and 6.917 is the denominator of the standard deviation. Okay, one thing I forgot to do is, what did I say? 691? 6917. 917. Okay, I still have to divide here, right? Square root of, we don't call sample, but subject size, which is, I think, 11 subject. Yeah. Okay, so let's see. So this is 11, right? 11. Okay, so let me plug in this one. Let me put the equal sign. Okay, so let's see. So numerator is going to be 7.634 divided by, I put the bracket here, 6.917, another division, divided by square root of 11. Close the bracket, so this is 3.644. Now we get the p-value, right? P-value of one side, let's see, because it's going to be less than, right? 6.36. So we have to go to 6. So I just write down t equals 3.66. Okay. Okay. Now I go to second distribution, TCDF. That's number 6. TCDF. We consider this one to go to higher. So let me put this one tail and 3.66. Higher is infinity, so 1 E99. Degrees of freedom is 11 minus 1, which is 10. Paste here. 0.0021, which is quite rare, right? So if it's, I believe it's one side, 0.021. So if it's that rare, right? Let me see, everything is okay. 0.027, but mine is 0.021. Right? You can see it. Right. So it's much smaller than the p-value. P-value is 0.05, and this is 0.0027. So it's reject no hypothesis. There is strong evidence it was different. Yeah. So you can read this conclusion is because p-value is 0.0027 is less than alpha level 0.05, we reject no hypothesis. So what is reject null hypothesis? The difference equal to 0. We have convincing evidence that the true mean different placebo minus caffeine is in depression score is positive for subject like this. Okay, uh, the score is positive means there is a bigger uh, uh, rate for depression. Okay, so now just looking at the data, uh, the true mean change in depression score mu of difference is greater than 0. Okay. However, it's possible that there have been no change, and we get the result this much larger than difference of mu equals 0 by lack of the random assignments. The significant test tells us whether this explanation is plausible. Okay. So that's the end of, maybe you can go through, read this through. And that is at the end of our chapter 9 assignment. And this is the preparation for upcoming test after the spring break. So this is a little music for spring break, and I hope you enjoy it. Have a nice break.